Hello everyone, I found this problem on the Geeks for Geeks website. Given two unsorted arrays, find all pairs whose sum is x. Who was interested? So I had a look to the solution. Here we are on their website. First they give a naive approach and then they explain in a more efficient way how to do that. So this is their solution, and when I read their solution I was thinking, do we need all this for loop for the solution? The point is that because I come from R, in R we avoid writing for loops when we can do that naturally. But I was thinking that also in Python we can avoid because we have NumPy. So I wrote my solution without using for loop. So let's check it. And by the way, before starting, I'm not a software engineering. I know these are questions prepared for software engineering, so my approach can be quite different. So let's have a look. What we need is NumPy. So let's import it. Now I want to start with a very simple task. What we want is to find if the sum of at least one element in a non-empty array A and at least one element in a non-empty array B is equal to a given number that we call target. Note, okay, vector A and vector B can have different length. I used vector as in R, okay? Let's leave like this. So I show you in a moment why we are starting from this naive problem. And here, what we think is to approach very simple with just a nested loop. For I in range length A, for J in range length B, if AI plus BJ equal target, return true. And we break the loop because in this simple example, we want just at least one element in the two arrays. Okay, so this is really the naive approach. Let's run and let's check it. And we have the answer is true. The target is 7, and as you can see, we have 3 plus 4 7, but we have also 5 plus 2 7, but only at least one. So we found one pair, so it's enough for us. What is the point here? The point is that we realize that AI plus BJ is equal to target. Target minus AI is our solution. So we can create an auxiliary object given by target minus A. And then we can loop over this auxiliary object. By doing like this, we remove one loop. But we are not doing like this now because I claim that we can remove completely the loop because we have NumPy. So let's check it. So we are solving the same problem now with NumPy. And this is my solution. I generate the auxiliary object here, and then what I'm doing, I'm checking NumPy is in, so B in the auxiliary object, if any of them will return true, else false. So the previous function, I just rewrite like this with NumPy. Let's run, and let's test it. This is true. Now let's move to the real problem. We want the numbers. What are the numbers? The pair of numbers that sums to target. The approach is similar. I generate the auxiliary object, and now what I'm doing here, I'm finding with NumPy where the indices where they are located to subset the B object, and this becomes our solution. And then I'm selecting the pairs by subtracting B from target. And here I just want to return this as a matrix, as a transpose of the matrix. And then here we have, if it's true, the numbers that sums to target are, and we have the rest object, else no number sums to target. Let's run and let's test it. To test, I'm replicate data sample. So the first one is this one. So let's run. Our solution is 5, 3, that sums to 8, and 4 and 4. Let's check. 4 and 4, 5, 3. Okay, so the other example is this one. We have 1, 8, 4, 5, 5, 4. Let's run. We have 4, 5, 5, 4, 1, 8. Okay. The next example is this one. Let's check. We have 1, 7, 4, 4, 5, 3, 7, 1. As you can see, they sum to 8. And here, where's that? 1, 7, 7, 1, 5, 3, 4, 4. Last one. Yeah, this is the last result. 6, 2, 4, 4, 6, 2, 7, 1. 62446271. So it seems that is working, and we did without using any for loop. Here I have additional tests, so let's generate some random numbers here. So we have A and B, and let's check it. For example, if the target is 12, so we know that 18 minus 6, yeah, 18 uh, minus 6 here gives 12, so this should be true. This is true. Also here we have another true. Let's check the numbers. We have 12 plus 0, it is 18 minus 6, and they are both numbers that sums to 12. Let's check other example. We have minus 19, for example. This is true, true. And here we see that we have minus 14, minus 5, minus 21, minus 19, 0, minus 13, minus 6, minus 18, minus 1, that sums to minus 19. Now let's set as target 1000. So this force, the first one just return nothing. This one return false because we added the else statement. And here we have no number sums to 1000. So it seems that they are working. Now let's move to another case where we have one array only. And let's move with a simple case with no restriction. So with no restriction, I say that we can use the same function just by repeating the same vector. So here, for example, we use the vector A and we check which one sums to 10. So first of all, we know that it's true. And which one? The numbers are 20, minus 10, and minus 10, 20. But now I want to add a restriction. So we can use same element twice. Meaning, for example, that let's say the target is 8, so we have a different combination to sum to 8, 1, 7, 3, 5, but we have also 4, 4. This solution we are not going to accept, okay? So we cannot use 4 twice. So what I'm doing here, first of all, I'm counting the unique values. So I'm returning the values, the unique values and their count. And then I subset for duplicates. So I'm counting, if count is greater than 1, I'm generating this A1 object. Okay. Here, our if statement is if A1 basically is not null, A size is greater than 0, and any A1 times 2 equal target. What do? We want to keep only not duplicates. So count equal to 1, meaning we are removing all the duplicate values. The reason is because, again, let's consider the example 4 plus 4 equal 8. If the target is 8 and we don't accept 4 plus 4, we can remove 4 plus 4. The reason is that if we have 1 4 to reach 8, we can reach only with another 4. We cannot have another number, so that 4 cannot be used by in another combination. So we just remove them. Else, meaning that A1 plus A1 is different from target, we keep all unique values. Then here the same, I subset the object. In this case, I'm setting the auxiliary object, but I'm taking only the unique values. Again, I generated the A. Because here we are working with the same array, we have just one. That what we do, we are deleting where A is equal to B, where the indices are the same. And then I'm returning only half of the object of A and half of the object of B, because I know that the remaining half will be the same. We just want to returning the just the individual pairs basically. And then here I store again the result. So let's run this one and let's check it. So the numbers that sums to 3 are 4 minus 1. Okay, 4 minus 1. And yes, we don't have any other combination. Let's check this other one. The number that sums to 19 are 13 and 6. So we have 13 and 6, but there are no other combination. Okay, seems fine. Last example here, instead of returning numbers, let's return indices. Now the only difference here is that I'm making a copy of the original vector, because this original vector A basically is modified here and here. But because I want to return the indices, I store the original values in this A0 that I'm using here. Okay, the rest is the same. Let's run. Let's print again A. So this is our A. Let's check it. The target is 8. The numbers that sum to 8 are at the indices 2, 3, 4, and 6. So 0, 1, 2, so 2 and 3, okay, they sums to 8. Then we have 4 and 6, they sums to 8. And remember that we are not taking the double values here. So it seems correct. Let's check with the previous function, which are the numbers. So we have 9 minus 1, 5 and 3. Okay. 9 is 6, 4, and this 2 and 3, 5, 3. Okay, let's check last example. Target is 9. We have quite a lot of numbers here. 0, 2, 3, 5, 7, 8. These are the indices. Let's check the numbers. The numbers are 6, 3, and 5 and 4. We have a 6 here, a 5 here. This is 0 and 2. 3 also comes with 6. And then we have 5, 7, 8. So 0, 1, 2, 3, 4, 5, again 6. And then 7, 8, because 4 and 5 sums to 9. Okay, this was my solution. I don't know if it was interesting, but just a different way to approach the problem, okay? I hope the video was interesting, and if you enjoyed the video, see you in the next one.